Hi guys, just a quick video on an introduction to Unity. It's just basically going to run you through the interface of Unity and very quickly introduce you to the concept of a transform, components, and how to add a script. Okay, so without further ado, I will open up Unity Hub. And what we will do here is we will create a new project. Okay, now, so new project, we basically, there's lots of different templates for what you want to do, things like VR and AR as well, but we're most interested in the 3D core. So I just want just the basic 3D, and I'm going to give it a test name, or just a temporary name called test 2. And I'm just going to see where um, the location is. Okay, so I'm just going to put this on, just make sure, desktop, select folder, that's fine. Okay, so this is the desktop. So I'm just going to create the project here. Okay, so this might take a while because even an empty project, a project that has no actual content, has an awful lot of files. Last time I checked, it was just short of 17,000 files and 1,000 folders. So it's creating those there. And obviously it needs them to run the engine. Okay, now if you want to look at how you might store these on GitHub, you can check my other videos in terms of how to. It doesn't actually use all of them to recreate projects, but it does need all of these files to run. So as you can see, test2 was created on my desktop here, and if I open it up here, you'll be able to see that it's creating the structures and the files in there. So it's populating them away. Okay, so while that's happening, I would like to also bring your attention to Unity's own website. So Unity's own website is obviously got the downloads, but in particular, I talk about the learn aspect. So it's learn.unity.com. And when you log into that, here we go. So you can sign into this with your Unity ID. Obviously, you will need a Unity ID, which we covered the last day. So um, okay, so just in case somebody is watching this video new, if you're starting and you have Unity Hub, again, you have to install your version of Unity first. You usually do that through by installing the Unity Hub and getting the Unity Hub to install it. And before you do that, it will ask you to create an account and to sign in to that account. So I've signed in the Unity Hub up here. You can also sign in when you're working with the Unity Learn website. You can sign in there, and it will allow you to keep track of your progress in terms of whatever tutorials you want to do. So you have basically pathways that basically describe how well what you can do in Unity. And in particular, what I'm interested in showing you here today is the Unity Essentials, effectively foundational level. So if we want to just click on that here, in particular, there's two videos, the first two that are of interest to me for ye here. Okay, that's good. There, there we go. So I'll just start the pathway here. Oh, sorry, it won't allow me to do this without signing in. Sorry. Okay, so when you sign in, as I said before, it's similar to an awful lot of the oh, okay, so, oh, another time. So basically it gives you experience, XP points when you do the tutorials. Okay, so the ones that we're interested in that I'd like you to do is getting started with Unity, which will tell you how to install, and then it'll kind of give you a brief interview, a brief description of what's going on here. Now, Unity version changes regularly. It's three or four revisions a year usually. So just watch out for that. This will have a more up-to-date version than possibly the video that I'll be showing you. And it will be probably more thorough because at the end of the day, I just want to show you the essentials today. So this will go through installing it and just kind of a quick view as to what's going on, and then exploring Unity. Um, but so it's getting started with Unity and exploring Unity. This one here. Okay, that's kind of more a description of what it can be done, etc., etc. So maybe not so much this one here. Okay, but in particular, the first one, the Unity Essentials, is really worth having a look at. Okay, hopefully I'll include that as in a link at the bottom, but it's learn.unity.com. It's no big deal. It's fairly straightforward. So this is the Unity game engine, okay, and it's made up really of 1, 2, 3, 4, okay, possibly 5 kind of areas that we really need to have a look at, and we need to understand what's going on. Okay, so the first place we're going to look at is obviously you have this window here, which as computer programmers and gamers, you recognize as kind of being something that looks like a 3D view of some sort. Now, if you look in here, you can see there's what looks like a camera there, and that's what looks like a light there. And if you see on the left hand side, we have a camera and we have a light. Okay, so if you click on these, you see that it's selecting the objects in the view, and you can also click on the objects in the view, and it will select them as well. Okay, now this is what we call the scene view, and you can navigate around the scene view clicking this widget to align it with the given axes if you want. There's various other things. You can press the middle button on the mouse and kind of pan it like this. You can roll to zoom in and zoom out, roll the mouse wheel to zoom in and zoom out. I think it's Alt and Alt and left click, and you can rotate around the object that's been selected, etc., etc. So again, all those essentials will be covered in the Unity tutorial that I mentioned, but it's also, it's good to know them now. Now you can mess about with these tools here. They're fairly self-explanatory. So this is a move tool, which allows us to move objects, etc., etc. But we'll come back to that in a minute. Okay, so we obviously have the views here of this we'll call the scene views, and the scene view typically you have at least one of them usually, and it's typically got gizmos in them visible. So things that help you to describe kind of things like the orientation, what it's looking at, and where it is, and what way you could move it. Okay. Whereas the game view, so if I click on the game view, so you can see there's 2 tabs up here. If I click on the game view here, then it shows you what you can see in the game. Now, there's nothing in it, so all we're seeing is effectively an empty screen. Now, this is what we call a skybox. We see kind of what's supposed to be the horizon and the sky there, but that's all we see because there's nothing in the game. Okay, so you can also, if you wish to, change the layout. So the layout is up here. The default layout is the one we have. So you can change it to like this. So you can have 2 things open at the same time. You could go to a 4-way split where you have 4 of them from different perspectives. Okay, that sometimes can be very handy when you're trying to zoom in on a specific behavior of a given character at a given time. Then you can have tall, again, wide, depending on the type of screen you might have. And it is, if you do have the opportunity to work with this at home or in a different environment, the more monitors the better. Okay, because really you can all these can be undocked and you can place them somewhere else. So if I wanted to, I could literally grab the scene view here and I could pull it out and move it somewhere else. But I'll just put it back where it was because I'll keep it as well. Now I'm going to go back to the default one just so we keep things as normal as possible. Okay, so so you can see this over here. The next panel is over here. It's called the hierarchy. And what the hierarchy does is it describes, well, if you're talking about a movie, every movie is made up of scenes: action, scene 1, scene 2, scene 3, etc. And it's the same in games. Now the scenes might be level 1, level 2, it might be just menu and main game scene or whatever. So you will constantly be making up different scenes. Now we'll be using scenes in things like, well, I typically would use scenes to test, a specific thing, I might have a character that I'd like to see working on his own, so you don't have to load everything in it. Just create a scene specifically to test the character and how that character interacts with the world. So you could create those scenes, and those are very handy to zone in on specific things. And when we're doing what we call prototyping, which is making up, a character in a game or an object that's in the game and seeing how it interacts with things, you can just break them out into what we call test scenes to make these things work. Okay, so the scene is described here in the hierarchy, and obviously, if you want to change scenes, then you would need more than one. And typically, this is what a scene looks like. Now we'll come down here. So you'd click on a different scene and it would open up a different scene. So it's easy enough to navigate. Again, now I'm going ahead of myself by working with down here, but we understand the fact that if you have scenes, more than one scene there, you will have something there that will be able to get you from one scene to the other. Otherwise, it's kind of useless. Okay, so here the hierarchy, this describes what's in the scene. And as you can see, the only things in there at the moment is the sample scene. Now, if we want, we could rename this. Save scene as, and we could save the scene as Rob's first scene. It doesn't matter. Rob's first. So that calls that Rob's first scene, so that's fine. And all it has is a camera and a directional light. So let's put something in there just to see what it looks like. And I'll just point out this pull down menu at the very top. Okay, file, edit, assets. Now we'll be dealing with these quite a lot, but we'll kind of deal with them on as you know, as you need them basis. So what we're going to do first is we're going to add something into the scene that we can look at and we can manipulate. Okay. So to do that, everything in a Unity game is called a game object. Anything you see that exists in the game is a game object. So there's a pull down menu here just for game objects. So if we click on that, what I'd like anyone if you're doing this with me as we go, so you just go to 3D object, and you can pick any one of these some of these are very interesting down here. Train maker, trees. I haven't even seen WinZone before. I'll have to check that out. So these are all objects we could put in there. Okay, so I'm just going to pick a very easy one, a cube, and we throw that in, and the cube appears there, and it also appears in the hierarchy, because obviously everything in the hierarchy will be in the scene and vice versa. Now, that cube might be our character, it might be a table, or it might be a block, or whatever. So we could name this whatever we wanted to over here. In the same way, you can right click and rename or whatever. And we can, as before, select them as it goes. So that's really all this in the scene. We can add as we go multiple objects, and you can create your whole entire scene in here, whether that's be terrain or whatever, trees. You will see it all appear in here. Now, get quite messy, but you can do things like kind of folder type structures. They're not without their consequences by having folder type structures in the scenes, but we'll come to that another day. Okay, so we have our scene here, and it's got a block in it, and let's have a look at this block more closely. Okay, so that's pretty much described what the hierarchy is. We've described what these windows are, whether the scene view or the game view. Now you can see the game view just has the cube floating in space, which is good. And now we'll move over here to this fella here on the right, okay? And this fella is called the inspector, okay? Now the inspector is exactly what it sounds like. It just inspects. It basically allows us to click on an object and examine that object, okay? Now, what I'd like to do here is, what I'm going to do is, if you look at the object, it kind of looks kind of messy in that there's lots of stuff going on, but I'd just like to emphasize the fact that it's broken up into separate objects. And you can see that these objects here are pretty much all expanded, this little triangle here. So if you click on each of those triangles, you can close those objects down just to make it a bit neater and tidier. Okay. Now, so that means really this cube, when we inspect it, has got 1, 2, 3, 4, 5 things. Okay, now we can see add component. So those things are called components. Okay, so this cube has 5 components included with it. It's just they're pre-installed, that comes with the cube. Okay, let's have a look at the other two just to make sure. So main camera, again, closing things down. We don't need to look at them. So we have 1, 2, 3 main components in the camera. Okay, one of them being what we call the camera. So obviously there's some code or whatever you want to call it, functionality that has to deal with the fact that this is a camera, which makes sense. And the one here is the audio listener. The audio listener, it makes sense too, because if you're playing a game, you would expect the sounds to, you'd want to hear from the perspective of where you're at, from where you're looking at. So when you're looking at where the camera is your point of view in the game, so when you see the audio listener, it would be natural to put the audio listener there so that 3D sounds and stuff will sound like it's in the right place, stereo to the right, one to the right, and some to the left, etc., etc. Now this other one called transform. There was one that the transform in the block as well, if you remember correctly. So that was common to both. And let's have a look at the main camera. And the main camera, oh sorry, not main camera, the directional light. And again, the directional light has 2 components, a transform and a light. Okay, so obviously there's different types of lighting. You might have a light that's a point light, like a bulb or a candle, which sends light in all directions. This light here is what we call a directional light. It's kind of like mimicking the sun in that, when you're on the surface of the earth, well, for a small part of the surface of the earth anyhow, it appears that all the light is coming in parallel from the same direction, because the sun is so big it's just sending the light in our directions. It might as well be, rather than coming from a point, it's coming from a kind of a long distance away. So the lines, the rays are coming in parallel. Okay, and obviously depending on, I mean, we've all seen situations where if you have a light, you can make your shadow, say like a candle, you can make a shadow really big by bringing it in close, but obviously with directional light, the shadow would be pretty much the same size all the time, that sort of thing. So obviously there's functionality there that needs to be addressed. Okay, so that's what that does. Again, don't worry, you don't need to know about the functionalities, you just need to know that they work. And if you're looking for something that you want to change it, then you might go into it and just look for the specific part that you need to change. Okay, but again, the thing that I'm interested in again is that the transform is there again. So the transform seems to be common to them all. In fact, every single game object that you put in a game has to have a transform. Okay, so for transform, read game object, for game object, read transform. Now, what is a transform? So if we have a look at the block and we expand the transform, we can see the transform is made up of position, rotation, and scale. Okay, and for those of you who might have a little bit of mathematical background, basically there's a section of maths called linear algebra, and you can do what we call transforms, which are linear transforms, which are basically matrices that make things move and make things rotate and scale, etc., etc. So, or if anybody's had any experience of the graphics pipeline, they'd know what these matrices look like. Now, the matrices are just rectangular blocks of numbers. As it happens, they're going to be 4 by 4 blocks of numbers. You again don't need to know about that. all you need to know is that the transform here describes something to do with how you place the object and how you orientate the object in the scene. So, for example, if I was to change the X to 2 there, you can see it changes the value. In fact, if you hover your cursor just to the left of the little space for the number and click, left click, and you can move your cube left and right, you can see the value changing. So what we're looking at here really is, okay, it's the value of X. So what we're really talking about, it's the X, Y, and Z of coordinate geometry. X being left to right, Y being up and down, and Z being into the screen and out of the screen. Now, well, what's going on here? As I increase the X, it's moving to the left. Well, that's because the point of view that we're looking at is not the same as our normal point of view of our X, Y, and Z. So if I was to look at the gizmo here and see if I could arrange it the way I'd like it, I would like Y being up, which it is, and you can see now X is to the right, okay, which is what's good. So if I now increase the X, it goes to the right. If I decrease the X, it goes to the left. It's good. If I increase the Y, it goes up. If I decrease the Y, it goes down. And similarly, if I increase the Z, it goes into the scene. And if I decrease the Z, it goes out of the scene. Now, again, we won't worry too much about the positive and negative to Z, depending on the engine you use or the mathematical. Okay, so it's called the left-hand rule and the right-hand rule. It doesn't matter. It's all relative to the camera anyhow. Obviously, the reason the direction you look at it, the direction it's moving will depend on where you're looking at it from. Okay, but again, the only thing I want you to get from this is that if you want to move this object, you need to find the transform, get the transform, and go into the transform and find the position inside the transform and change it in that way. Similarly, if I wanted to rotate it, okay, you can rotate, now changing the Y value rotates it this way, changing the X value rotates it this way, and changing the Z value rotates it this way. Okay, now I'm not going to into the actual rotation there, but effectively what you're doing here is when you're changing the Y value, you're rotating around the Y axis. So like if you imagine the pole being the axle of wheels of a car, then that the Y would rotate as the wheels would if that was the axle, if the axle was going straight up in the air. Similarly, if the X was the axle and we change the X values, then it would rotate like that. Well, that's really a wheel's motion. Okay, and similarly, the Z would do something similar. Okay, now I don't like Euler personally. Euler angles, the way they describe them. I use something slightly different, especially when we're actually doing rotations, but we'll come to that a little later. Okay, so the transform is basically the thing that I am most interested in at the moment. Okay, and we can see and adjust live and create things and move things and make things bigger or smaller by just adjusting the values in the transform. Okay, or as I said before, you could use the tools here and it does the same thing. Okay, now that basically is what the inspector does, and obviously the inspector would allow us to inspect and look at and possibly change the other components in the that are attached to the object as well. So, you know, the block, you really wouldn't want to go messing in with these, the mesh filter. This is basically the mathematical model that describes the cube. This is the mesh renderer. How do you actually draw it? Again, that's quite complicated. I wouldn't be asking anybody to mess with that yet. The collider, it's an interesting one. The collider basically is, well, if you're creating a game, it's really when things hit each other that you get the most fun. You know, whether a bomb hits something or you crash into a wall, that's where the interesting stuff happens in a game. And if you don't have a collider, the engine will never be able to work out when things would collide and they just go right through each other. Okay, The material here, just standard material, just looks white at the moment. You can literally pull in uh, literally a picture of yourself if you wanted to, or a picture of grass, or a picture of a crate. Bring it in here and it will convert it to a material, and you can put it on there and make it look pretty nice. But again, that's another day's work. Okay, so we'll come back to this add component in a few minutes. Okay, so the last area that I'm interested in showing you then is this area down here with the project and the console. Now, the packages here, don't worry about that, just minimize them. It just, Unity just adds a lot of stuff that you may need or you may not need. It's not of interest to you until you do need them, but most of the time we won't need them. Certainly won't need them in first year anyhow. So here it just has, well, what we're looking at here is effectively like Windows Explorer. It's just a way of exploring everything in our game or in our scene. Okay, so in terms of everything being, every file we make, every bit of media we bring in, whether it's materials to make our box look like a crate, or whether it's some music, or whether it's a model of a character or whatever. So all of these will go in here somewhere, and we can, if we want to, create a folder, or we can create lots of other stuff to do it. So the only things we have in here, so there's a folder with scenes, and that was the sample scene there, which was the scene that was Rob's first scene before I renamed it. And obviously it didn't get rid of that, and it's also got Rob's first scene. So I'm not sure what would happen if I click between them, but they exist as files, one of the 17,000 odd files, but they do exist as files on the directory structure now of our project. And obviously you'll see the folder here as well. Okay, so you're able to use the search bar here if you wanted to search for things as well. So the only things, two things here, Rob's first scene and the sample scene. So if I type SA, when you see the sample scene, you can find things quite quickly there. Okay, so that's good there. So let's move on to the final bit of this, where we see if we can manipulate or put some code on an object. Okay, so it's great to be able to place and move and scale our object here, but obviously in a game you're not going to do it. You want it to happen automatically without having to mess about with the transform physically here. Okay, and that's obviously going to be done through code. Okay, so to do that, you would put the code that you want to manipulate an object typically on that object, add it as another component. Okay, now not all the time, but sometimes you can have components on other objects that will control objects that they're not connected to, but we tend to try and kind of minimize that as much as possible. Okay, so let's put a piece of code on this that will allow us to move this in whatever way we'd like. Okay, so to do that, we just go to add component. As you can see, there are a lot of possible things that we could add. Okay, we won't be going near half of these or a quarter of these even. We'll just be using one or two of them this year, and we'll see where we go from there. So in particular, what I want to do is I want to add a new script. Okay, so this script, I'm just going to call it cube control. Okay, very original. And I'm going to create and add. So you put the name, new script, cube control, create and add. So you click on that, and that has created, if you look down in your assets down here, it's created a new file. Okay, if you were to click on it, the inspector will actually show you the code. Now the inspector can only show you a limited amount of code, but because it's empty for all intents and purposes, it's able to show you everything that's in it. Now, in particular, we have a start and an update. Okay, this is typical. The three things that you watch out for scripts that go on a Unity object are, one, that it's what we call a mono-behavior script. That, for those of you who have done or that have an understanding of object-oriented code, this is basically means cube control is inheriting from mono behavior. But that's not something you have to worry about, but it just allows us to use all of the functionality that we would hope and expect would be there. Okay, start is called the first frame of the update, so before the first frame of the update, so basically it happens at the start. And update is called once per frame. Okay, now what do we mean by per frame? Okay, so what I'm going to do is I'll just show you what happens. So if I go to game here, so this is the game view, and all we've done is add the cube. We haven't told it to do anything. If we go to stats, we can click on the stats. Stats will appear. Now it's not running, so you press play to play your game, and all it should do is show us the cube. So I'm showing us the cube, and it's running at 100 and 200 frames FPS, 200 frames per second. Okay, in other words, the amount of time in between one frame and the next is about 4.5, 5 milliseconds. Okay, so what does that mean? It means that the update here is running, and it's running again and again and again and again and again. Was it every 5 point something milliseconds? Okay, so it's happening a lot. Okay, that's important to get your head around that because it's a slightly different way of understanding how to code, because it makes a big difference in terms of code. So that's fine. We have the code here. So obviously we'd like to be able to put something in here to make this guy move. Okay, so if we're going to do that, we need to open up what we call an IDE, an integrated development environment. Okay, and the typical one that comes with Unity, the usual install is the Visual Studio, either community or enterprise or whatever, whichever one is available to you at the time. Okay, so we need to open up that. So basically this, if this is done right, it should basically help us so much with our coding. Okay, really when you're starting off coding first, I think it's very important to have a decent IDE that would, at least point you in the right direction as to where things are going wrong, because things will go wrong, unfortunately. So how do we open this? Now, the first thing you do before you do this, now, most of the time, well, usually if you do it once, it's enough. But you want to make sure that you're linked properly to the proper IDE, in this case, Visual Studio. And in Unity, the way you do that is you go up to the edit, top left here. So you go to edit, and you scroll down to near the end, preferences. And then you click on external tools. And the first time you load it, typically it might be open file by extension. You do not want that. Okay, you do not want that. What you want is the Microsoft Visual Studio 2019 in my case, whichever one is there. Okay, now if you've installed it, usually comes as one of the options for install, which I would strongly encourage. I'm not even sure you have the option of not installing it, but make sure you include that in the install when you're installing Unity. It comes, as I said, with Unity. Okay, so we close that, and that means hopefully it's linked properly to Visual Studio. And then what I encourage people to do, it's not necessarily essential, but what I encourage people to do to open it is just go to assets and open C# project. Okay, that's maybe more in to kind of emphasize to the user rather than the Unity engine that we want to open up the entire project, not just maybe one file. Okay, so this is opening up here, Visual Studio, and what we're doing is, what we want to see is we want to see the Solution Explorer here on the right, and we want to make sure it says 1 of 1. So basically that indicates to us that the project has been loaded and is linked. Okay, so if I click on the assembly sheet C# here and I click on assets, I can see the kubecontrol.cs. CS stands for C#, which is the language which we use here in Unity. So if I click on that, it appears, the code appears in this window here. Okay, so here, as before, we have the start and we have the update. Now, our goal is to move the cube in some way, shape, or form. Okay, now, how does that work? Okay, well, let's go back to Unity, see if we can remind ourselves. If we go to the cube, to make the cube work, it involved changing the position of the object. Okay, so if I want to make it move up, I change the Y, or down, I change the Y value. If I want to move it in or out, I use the Z value or the X value. Okay, so that that all works. So that's reasonable. But again, we have to understand kind of how things are structured, and more to the point, how do we access the things that are structured? Okay, so if we look on the components here, we added the cube control script, so it's now visible as a component on the block. Okay, so um, the positioning of the script is extremely important. Okay, we'll come to that, as I said, possibly in another tutorial. So here we have, and we're in the update. And what we do, if we're changing the position of the object, we'll start so easy. So we're changing the position. The easiest way to change the position is, well, where was the position? The position was in the transform component. Now, because every single game object has to have a transform, they made it easier for us to find it. So they made it available to us straight away. Now, just go through that just quickly. If I type TR, it automatically guesses what you want. Okay, so again, especially when you're starting out, take the help that you can get and be as cognizant, as aware of what's going on in front of you, because it's trying to help you, and they're getting better and better at trying to help you to code. So the more you read, the more you'll understand. The more you'll understand, the faster and better programmer you become. So if you say hover over here, you can see that the transform, it's suggesting the transform, and it's basically saying the transform that's attached to the component of this game object. Okay, so that's obviously what we're looking for. So what, and I'll just point out too that it's little t transform, not big T transform. The reasons for that we'll go into it later. Okay, so this is the T transform. So I don't, well, being lazy, I don't type it out. Once I get to this form, I just press tab, and tab finishes it off for me. Well, I suppose I'm being slightly facetious when I say I don't type it out. I think it's better not to type it out, because without best will of the world, you're going to make mistakes. Whereas if you tab it, you're going to pick the right one, as long as obviously you're picking the right one in the list. Now, most of you will not have done object-oriented code, and basically what happens in object-oriented code is you kind of break up your code into packets or groups or areas, and you give them a name. So the name you typically give them is called a class. Okay, so the class might have uh, you know, lots of methods just to do with that class. Okay, so the transform, if we go back to the code here, obviously the transform is going to have something to do with position, something to do with rotation, something to do with scale. So to get access to that, or to get access to the functionality or the objects that are inside a class, you just press dot. And as you can see, it gives you a best list. It's best guess at the list, and it's saying, you know what, you probably want position, okay, because it knows what we want. Now, if you don't see position and you just type PO, it will automatically, you know, you'll see that in the list. So again, I'm going to tab that to say that's the position. Okay. Now, again, when you hover over transform.position, it gives you information. Okay. The thing I'd like to point out here is that it's giving us what's it saying. It's saying the world space position of a transform. Okay, and it's saying it's a vector 3. Okay, and get and set means we can read it and we can change it. Set means you can set its value to something. Get means you can get the value. Okay, so vector 3, what's a vector? Well, for all intents and purposes, now the mathematician part of me is spinning, doesn't like what I'm going to say, but for all intents and purposes, a vector is a point. It's an X, a Y, and a Z. Okay, and basically it's kind of put down as, you know, a point exists as a single point. It's not, you know, it exists in space. even though we describe it using 3 values. Okay, so it's a single object, but you need 3 values to describe it. So if I want to deal with this, I might be able to change it. Okay, so I could say it's equal to something, but to make something move, you kind of really what you're going to do is you're going to change its position. So you're going to take the last position and add a little to it. So I'm going to use this symbol, which means plus equals, which basically means is just take the value and add a little bit to it. Okay, now again, I'm going to write 5 and semicolon. Okay, and this big red line underneath it means it doesn't like what I've written. Okay, so what's gone wrong? So if again, read, be aware, and try to learn from what it's saying. Okay, so what it's saying, the operator plus equal. So in other words, the operator is this plus equal, the thing that add to, cannot be applied to operands. No, I don't know why they use these words, but they're just things. Cannot be applied to things, one thing which happens to be a vector 3 and the other things which happens to be an integer. So what it's saying is, you know, it's all very well saying I wanted to add 5 to the y, but I didn't say I add 5 to the y, I just said add 5. That makes no sense because was I saying it to the x, to the y, to the z, or all 3 of them? It can't understand what you're trying to do. Okay, doesn't make sense. So to do this, what we're going to do, we're going to need to add a vector to it. Okay, so let's make it go up. So I'm just going to cheat here. I'm just going to write vector 3 dot. Let's see if it has anything to do. There we go. Vector 3 dot up. Now all code in Visual Studio or in C# finishes with a semicolon at the end. So that is saying take the position, add vector 3 up. Now, okay. What is vector 3 up? Okay, again, let's take a guess. Okay, an educated guess. X goes left and right. So obviously, if you want to go up, you don't want to go left and right. So the x is the first value of the coordinate, so that's going to be 0. The y is up and down. So you would envisage that this would be something to do with the y. The y would have to have a value in there to indicate going up. It's not going to be 0 because that would mean don't go up. It's not going to be negative because that would mean go down. So it's going to pick a value that's kind of the simplest, most kind of normal value that you can put in there that would indicate up. Okay, and what's that value going to be? Well, it's not going to be 23 or 57. Okay, it's going to be a simple value, and the simplest value other than 0 would obviously be 1. So if you hover over it again, it's basically saying, you can see shorthand for writing the vector 0, 1, 0. And obviously, we're not going in the z as well. Okay, so that's our first line of code. And that's basically saying move our position. So here's our position, add 1 to the y effectively, because it's adding 0 to the x's and z's and 1 to the y. Okay, now to make this work in Unity, all we need to do is make sure it's saved on the disk, and Unity will take care of the rest. Okay, now being a bit OCD-ish or anal or whatever you want to say, I like to build it just to see all errors are not errors in here. The reason I do this is because if there happen to be a lot of errors, rather than finding out in Unity and then having to come back, I would rather see them here and get them right here before I hit Unity. Okay, but that's just my choice. Now, errors can happen even if you don't see the little red line. Okay, so if I go now down to back to Unity, and if you click down here, you can see this bottom right here. It shows show progress details. Okay, usually, well, if you arrive in early, sometimes you see a little roundy thing to say that it's uploading, and if you see nothing, it usually means it's up to date. If you want to be absolutely sure that the file has been updated, you can click on the C# script here, and you could get a preview of the file, and you can see the code transform.position plus equals vector 3 up. Okay, so let's run that and see what happens. So if I press play, and it takes a while, first time especially, and it's gone. Okay, as you can see, if we check the inspector, we're already up at 1,000, 2,000. Okay, so what's happening? What's happening is we're running at 200 frames a second, and we're adding 1 on every frame. So it's going up by 1 every frame. So it's going up at 200 units every second. Okay, so it's way too fast and we've no control over it. Okay, so happy days and not so happy days. Okay, so what what can we do about that? Well, we could make this a lot smaller. So I could go, well, how can we make it smaller? Okay, so if we want to make something smaller, we can, if you want to, if you your bank account, if I said I was going to multiply your the amount in your bank by a number, would you be happy? Well, it is. Somebody said it depends on the number. You don't want it to be -1. Well, I suppose it depends. If you're in debt, then -1 might be good. You certainly don't want to multiply by a half. And you certainly don't want to. You would be delighted if I multiplied by 100. Again, assuming that you're not overdrawn. Okay, so you can understand that when we take numbers, we can multiply it and it makes things bigger or smaller. Okay, um, so when I write 0.01 f multiplied by that, now the 0.01 is 100th. The f, just say, look, it's a floating point number. I just want to give you a heads up that it's not an integer or a string or anything like that. So the f just tells it that it's a floating point number. Now, again, I don't like this type of thing. This is called a magic number, and we avoid trying to put actual numbers into the code, but for illustration purposes, we'll be getting rid of it in a few minutes anyhow. Let's see how this works. So if I was to do this, this will work, should work, move it up 100 times slower. Okay, because we're reducing the vector tree up by, or multiplied by 100th effectively. So again, this one I won't build. My students will be delighted. My students prefer it when I just save because I think it's a waste of time. So saving it on disk should be fine. So I go back to Unity and I press play. And there it goes, moving nice and slowly. Okay, now that's great and not so great at the same time. Okay, what's right with it? What's wrong with it? What's right with it is that it's much better according to what we would have liked. What's not right with it? Okay, so in the college today, when we did this, we checked the frame rate, and it was up at 800. They're far more powerful machines than my laptop here, or I've got too much running on it. So the speed of machines vary from one machine to the next, but also a machine itself will vary depending on how much work you're asking it to do at any given time. So if, for example, some antivirus or something kicked in the background while I was doing this, then my object would slow down. Now that's not the way we'd like to play our games. So we'd like our games to move in a way that will be much more reasonable. Okay, so that something, a computer moving faster shouldn't make a character move faster, and vice versa. Okay, so how do we get around this? Well, we use a physics formula. Okay, there's a physics formula that deals with motion and speed, distance traveled, speed, and time. And it's basically, now this double line like that means it's a comment, so it doesn't count as code. And the formula that I'm going to use is show you is S equals U multiplied by T. Okay, so distance is S, equals U, which is speed or velocity. We're going to say velocity, and multiplied by T, which is time. Okay, so again, you take this for granted. You know you've done it every day. So you're traveling at 60 kilometers an hour for 2 hours. How far will you get? It'll be, well, it's obviously 120 kilometers. So the speed by the time gives you the distance. Okay. If this is going to work, the reason this is mad or goes mad when we had it the first time is because it was happening so often. So what we want to do is, instead of actually adding a fixed value to the position, we're going to use a speed, and we're going to use the amount of time passed to work out how far we should actually move our character. So, without further, I'm just going to throw it in here. So, vector 3 up means it's 1 unit in the y, okay? And the way we would envisage this as the velocity, if this was the velocity, vector 3 up, what that would mean is we're going 1 unit every second. Let's say units per second. That's the way we look at it. So if we're going to make this work, we're going to have to work out how much time has elapsed between now and the next frame, or the last frame. In other words, how far should it have traveled? Okay, if we're traveling at this amount of time for this speed, and we just multiply them together. So we need something to get that will basically work out the amount of time that has traveled since the last loop or the last frame. And well, let's take a wild stab in the dark. Okay, it's the amount of time that has elapsed, so it makes sense that we should be talking about something like time. Now, press TIM, and time has appeared, and if you can see, it provides an interface for getting time information from Unity. This is information about time, which we want. So we tab that, we press dot, and we have a look at the choices. Okay, so the time in seconds since the game started. Well, that doesn't make sense. We want the amount of time since the last frame has occurred, not the last since the game started. Okay, the time, that's the time at the beginning of this frame. Okay, so this is the actual time. Okay, so in this case, it's 20 past 7. Okay, delta time, the interval in time from the last frame to the current one. That's exactly what we want. Okay, so we just tab or double click there to do time.delta time. Okay, now the delta time, I don't know if any of you remember your differentiation from first principles. If you did that, you use delta x to describe a little x, a little movement in the x, or delta y for a little movement. That's why they call it delta time, that's all. So let's build that, and we go back to Unity, and hopefully that's updated, and we press play. Now, and it's going up. So the question is, how fast is it going up? Now, if we look over here, 7, 8, 9, 10, 11, 12, 13, 14, it's going up a unit a second, which is exactly what we would have liked. Okay, so that's cool, that's nice. That's working the way we'd have expected it. Okay, so we have successfully made our object move in what we call a way that is not going to speed up or slow down if our computer speeds up or slow down, or not going to run way faster on a faster computer or way slower on a slower computer. It will appear to move the same speed no matter what computer it's on, no matter what situation it's in. Okay. The only thing that's going to change if you're on a faster computer to a slower computer is that the computer will draw it more often, quicker. Okay, so it will just draw it, one computer might draw it 200 times in a second, another computer might draw it 100 times in a second, another might do it 30 times in a second. It won't make any difference visually to the person looking at it. Okay, now that's all very well. It's not very much of a game, is it? Okay, so if it's going to be a game, then typically you're going to want to control this with key presses. So in other words, well, it doesn't necessarily have to be key presses. It could be the mouse, it could be a gamepad. You're going to have some input device that's going to basically determine whether the block goes up or down or left or right. Okay, and so if we were to, in English, say what we wanted, what would we say? Well, we'd say, if you press, what we say, up arrow, I want it to go up. Okay, so that's a good starting point. If we press up arrow, we want to go up. So let's see what happens if we start that. So if I type if, it automatically recognizes if. So tab twice to insert the if snippet. Okay, that's handy. So I'm just going to tab twice. Now it doesn't matter if you don't, but I mean, just see what happens. Okay. You can see this is what it expects of an if statement. Okay, so if something, now it's just put a true value in there. Okay, so it's always going to do what's in here. Now, what I want is I'd like this bit of code to only happen if it's in here. Okay, and I'm going to change this true to something that sometimes is going to be true and sometimes it's going to be false. Okay, so I just Control X, selected the line, Control X, cuts, and Control V, pastes it in there. Okay, so that just moves that. You could also move it by selecting it and dragging it. That will also work. Now, so what was the statement we said that in English? We said if you press a key or press up arrow, then do this. Okay, so the condition that we want is going to have to be replacing the true here. So let's get rid of the true. Now, how do we determine whether a given key has been pressed? Now, the way we do this, I mentioned before, we don't necessarily know that it's going to be a key press. It could be as you said, the mouse or gamepad, or who knows what other types of joysticks or whatever, what other types of input devices there may be. But in particular, they're all called input devices. Okay. I don't know if anybody, classically, if you treat computers as black boxes or computer programs as black boxes, you tend to call them, there are three process things. There's an input, a process, and an output. Okay, so the input is fairly classical description of the bit that goes in. So let's just try input. And as you can see, it does recognize it. And if we read it again, it's the interface. The interface is just the way of interacting with it into the input system. Okay, so that sounds good to me. So I'm going to tab that to say I'm going to select that, and I'm going to press dot to see what's available. And it again gives us the best choice or the best guess that it can do, because it's pretty good at guessing what we'd like. Okay, so we have get key down and we have get key, we have get button down and get button and get button down and mouse position. They're very good guesses. We said we wanted to press the up arrow. So this is get key. Okay, so key, the up arrows, all the arrows, all the letters and numbers on the keyboard are keys. So the question is, do we use get key or do we use get key down? Okay, now there's a very obvious correct answer here. Okay, let's just read them carefully. So the first one here is, again, just to emphasize, oh, sorry, apologies there now. Okay, there's, as I said, huge amounts of information available to us with this IntelliSense and this information, or these little snippets of text. So what we have here is a description of get key down, which has bool, and you all remember what bool was. Bool was a true or false value, because obviously we expect the key to be either pressed or not pressed, and it's going into the brackets of an if statement, which is expecting a true or a false value. So a Boolean value is a true or a false value. So this bool, when you describe what we call a method, the first thing that when you describe it this way, this is the output value, a Boolean value, true or false. Okay, and this is the input.get key down, and it's got a key code key in there. We won't worry about that for the time being. But what does it say? It returns true during the frame the user starts pressing down the key identified by the key code. Okay, now that implies that it puts it during the starts pressing down the key. Okay, so it only happens once. Okay, now that's very useful for situations where you only want, select this once or select this once or whatever. You will need situations like that. But in this context, this will, because we're moving our object up only a tiny bit each frame, you won't even see that happening. You have to press it again and again and again and again, and it will only move a small bit. So we need something that will be true all the time the key is pressed. Okay, so if we hover down to get key, you can see this returns true while the user holds down the key identified by key code character, the number parameter. Okay, so this is good. So I'm going to use this, and as I said before, the input is a class, and the get key is something within the input. the input to help us, or to help us with the functionality to get what we want. And the problem is, as we've written it here, is, well, again, go back to the if statement. If I press the up arrow, then go up. Okay, here, get key is missing some vital piece of information. Okay, what information do we need to give it? Well, we need to tell it what key we're looking for. Okay, and the way we pass information into, we call these things methods. The way we pass these things into this method is through, well, we put parameters, brackets here. We put them in brackets, and we call them parameters. Okay, and if I was to open up that bracket, it tells us what we're looking for. So it's key code P. Okay, now I could, there's what we call an overload, which basically means there's different ways that you can do this. I'm going to stick to the key code. The other way is what we call a string, where you just go, I could just do look the letter A, and that would probably work. But I don't like it, because what would happen if you try to do backspace? Okay, so if you try to do backspace, you go up, and then you go backspace, and it's deleted. But backspace is a key, so we should be able to do it. So to cover every eventuality, you just put in a key code. Okay, and the key code, and what do we say? Up arrow, dot, and we go up arrow. There we go. Double click, and we're done. So we have an if statement, which basically says if you have up arrow pressed, then we do this up, vector 3 up. Basically do this, move the character. Okay, so let's build that, see if it works. Happy days, success, excellent. So we go back to Unity, and now we press play. Okay, and we're running at 160 odd frames a second. Nothing's happening. Well, it shouldn't, because we're not pressing the up arrow. Okay, so I'm pressing in 3, 2, 1 now, and there it goes up at the rate we would like. Stop pressing, and it stops. Okay, so we have an element of control now over our object. Okay, so if we want it to go down, then you change the plus to a minus there, so minus equals vector 3 up. That will work just as well. If we wanted to go left, we might go vector 3 dot left or vector 3 dot right. Well, let's just have a look. I want to go left. Is there a left? There is. Left, vector left, that's perfect. So that will go left. Could it go right? Could it go forward? Yeah, forward exists too. Again, these are the vectors you'd expect. Forward would be not left or right, 0 for the x, not up or down, 1 for the z. Okay, again, if I was to build that like so, go back into Unity, press play, and if I press my up arrow now, it starts traveling away from me like that. Okay, and that's the very basics of getting a Unity project started, up and running, and getting a script on it. Okay, we'll continue with movement in our next video. Okay, so I hope that was helpful, and I look forward to seeing you all soon and talking to you all soon. Okay, so I'll stop the recording now. See you later.